Hey watchers, I guess you are alright. I'm Ashutosh here and I'm presenting my maths art integration project through this video. Mathematics, the language or art of saying many things in many different ways. It's my all-time favorite quote said by a great mathematician, Maxwell. But during teenaging, when I passed out to the 10th class, then I realized that there is no solution of an equation x square is equal to minus 1. Now if there is no solution of x square is equal to minus 1, then how can it be possibly true that is said by Maxwell? Well, this is what I am going to explain today. It is complex numbers. Now we came to know that x square is equal to minus 1 has no solution. But a mathematician called Euler didn't agree with this. So he devised a new term, iota, where iota was equal to under root minus 1. Oh, in other words, he solved our problem, which was x square is equal to under root minus 1. So, what do you think the value of x should be? Yes, it will be iota. Now let us learn that how this iota made a new sequence of the numbers called complex number. So the definition of the complex number is on your screen now. You can pause and read it. Now as I said that the iota made a new terms of numbers called complex numbers. That means I meant to say that any number which include the iota is called as a complex number. Complex number is often denoted by a Z. Some of these examples are on your screen, which are 2 plus iota 3, minus 1 plus iota 9 and 4 plus iota 7. Now let us know the structure of these complex numbers. So there are two parts of this complex number. The one that is a real number, in other words, which do not contain iota within it. On the other side, there is an imaginary part which contains iota. Tricky, huh? Let us learn it by an example. Let's A is equal to 3 and B is equal to 5. Since Z is equal to A plus iota B, so here Z is equal to will be 3 plus 5 iota. So here the real part of complex number is 3. On the other hand, the imaginary part of this number is 5. Did you catch why? Well done if you did. I have a question for you. Is 2 iota a complex number? If yes, then what are its real part and imaginary part? To check out the correct answer, you can check in the description. So we just learned a new series of the number, right? We already know that how to add, subtract, divide and multiply the whole number, natural number and all the real number. But what about the complex number? Let's begin the algebra of the complex number. Addition. So in the whole series we are going to take z1 is equal to a plus iota b and z2 is equal to c plus iota d, and we'll see that what will happen in addition, multiplication, subtraction and division. Now as you can see on your screen, the sum of the z1 and z2 is defined as a plus c plus iota in the common and b plus t. Now don't let your mind confuse you. We have just added the real parts and the imaginary parts of the complex number separately, where we have taken iota as common. You can pause to observe the equation. Let's take an example where z1 is equal to 2 plus 3 iota and z2 is equal to 4 plus 5 iota. Now the real parts 2 and 4 are added separately. On the other hand, imaginary parts are added on separately, taking iota as common. It's like the simple addition, right? We have just taken the iota as common and nothing more is present in this question. Now let's move on to the multiplication. Now, as you can see on your screen, the product is defined as AC minus BD plus iota AD plus BC. Oh, it's so difficult, right? Let's understand this formula rather than learning it. Now, here there is two terms a plus iota b and c plus iota d. We have just multiplied in the first step ac plus a into d iota plus c into b iota plus bd into iota square. Now we know iota square is equal to minus 1. So in the second and third step, we just replace the iota square is into minus 1. Now with taking the third step, in fourth step we have just separated the real parts and the imaginary parts as we did in the addition. Now we have again z1 into z2 is equal to 2 plus iota 3 into 4 plus iota 5 both in the bracket. Now we already learned the formula. So we would just identify the A, B, C, D and put them in the equation. But you can also follow the steps which are present on your right side. You will notice that even we do with the formula that the answer will be the same as we do in the steps. So it's better to keep it in short. Now our next destination is subtraction. So a difference is defined as z1 minus z2 is equal to a plus iota b plus in the bracket minus c minus iota d bracket close. Now we will follow the same step and separate the real parts and the imaginary parts. Then we will take iota as in common in the imaginary part. And that's how our equation arises in the front of your screen, which is a minus c plus iota common b minus d. Now let's have a question. So z1 is equal to 2 plus iota 3 and z2 is equal to 4 plus iota 5. So we would just put the values 2 plus iota 3 plus 4 minus 4 minus iota 5. Then we will separate the real and imaginary parts, which is 2 minus 4 and iota in common 3 minus 5. So our answer arises as minus 2 plus minus 2 iota. That's it for the subtraction. Now let's move ahead to the division. So here z1 is equal to a plus iota b and z2 is equal to c plus iota d. Now z1 divided by z2 can be also written as z1 into 1 upon z2. Am I incorrect? So following this, in the second step we have a plus iota b into 1 upon c plus iota d. But remember, we should never leave iota in the denominator. So to remove the iota, we would multiply to its conjugate, which is c iota d. Conjugate is nothing but for z is equal to a plus iota b it's z is equal to a minus iota b, and for the z is equal to a minus iota b, it will be z is equal to a plus iota b. In simple words, we would just change the signs of the number which is within the iota. Now by multiplying with c minus iota d upon c minus iota d, it will give our answer a plus iota b into c minus iota d upon c square minus d square. I would like to personally suggest that rather than learning this formula, we should divide in general, as we are going to do on your right of the screen. Now we have z1 is equal to 2 plus iota 3 and z2 is equal to 4 plus iota 5. Let's move ahead to the second step where we have 2 plus iota 3 into 1 upon 4 plus iota 5. Now we would just multiply with the conjugate or the denominator. So we are multiplying with 4 minus iota 5 upon 4 minus iota 5. And at last we would get 2 plus iota 3 into 4 minus iota 5 upon 4 square minus 5 square. Uh, let's move ahead because you can do multiply as you have already learned how to multiply. So in this video we learned a new term called to the nature. Thanks a lot.